so modeling log functions with regression equation. So regressions again. Okay, so we can use logs to represent a function. Now, it looks a little bit different than the logs you're used to. The regression equation is in the form of a constant plus a multiplier times the natural log of x. So it's actually using the natural log. Or same, a would be your constant, b is the multiplier here. And that's the form that your calculator is going to do that in. When we do our regression, we're going to use number 9. And it'll look like ln regression, natural log regression. Did I tell you the joke? Did I tell you the one with Euler? Okay, so Euler he was the mathematician who discovered E and how special E is, right? And the natural log. So hence why it's the symbol E. It stands for Euler. He's like, if I discovered it, it's going to have my initial in it. So Euler, what? No, I'm not done. It's kind of dirty joke. Okay, so what did Euler leave when he left the bathroom? What did he leave in the bathroom when he left the bathroom? A natural log. A natural. Yeah. Okay. There's another one. And it's a drawing, it's a picture. I have to grab it. I'll show you. You'll like it. Give me a second. Sorry for those at home and you just want to get the lesson done. I apologize. It's in here. Here it is. A little bit of a delay. Little bit of awkward delay. We're waiting. I feel like my computer's getting slower again. You think so? Okay. So here's the other one. So she's hot, yeah, but she's not natural. Okay. Anyways, that was funny. That is a good one. Just love logs. Yep. So we can also do a curve of best fit. So when it says estimate, really the regression is the estimate. The regression equation is the estimate. Okay, so this is a log graph showing changes in the decibel level. Now, in log equations, remember how we talked about that time is usually the x variable? Yeah. Remember we talked about that? And exponential equations are inverse of log equations. They're inverse. So often in a log regression, time is actually the y variable. Okay? Very, very often, time is the y variable. Now, this is an example where it's not, but when you come across these applications, often in a log, time is y. So you really have to read the question, because remember, y is always a function of x. So but not often in a log, we have to see who's a function of who. You have to really read the problem to see who's your y and who's your x. So here's an example of this logarithmic graph shows changes in decibel level, y, as a function of the relative sound intensity. So always y is always a function of x. Y is a function of x. And so when they describe it, they say the decibel level is a function of sound intensity. And so notice how your decibel level is y and your sound intensity is your x, because y is always a function of x. Okay, so looking at this graph, are there any intercepts? Okay, what are the intercepts we know? X-intercept is 1, y-intercept? None. I don't say 0 because then I think it's at the origin, right? And behavior goes from quadrant what to what? So it starts off at quadrant 4, and as we move to the right, it goes to quadrant 1. domain, what's the domain of this function? X is greater than 0, range, YER. And is this an increasing or decreasing function? Is it uphill or downhill? Uphill, so therefore it is increasing. So, which is uphill. Okay. By what factor does the relative sound intensity change with the decibel level increases by 10? This is by 10. So looking at this graph, this is its intensity. So if you're looking at the beginning, if this is 0 decibels, right? When is it 10 times the amount? Well, when our decibels increases by how much? 10, right? So when it's 10 times, our decibel is going to be 10 more. So 10 in this case. All right, so now let's get to the regression stuff. So grab your calculators. We all need our graphing calculators. We all do. Okay, so pushing stat. The usual, nothing, there's only one button that's different this time. It's nice that it's the same, so like by the time you get to your diploma, you know how to do regressions. There's no question about it, right? Okay, so we need to edit our data. Remember clear, go up to the top, push clear, don't push delete. Then you delete the actual list. So here's our x's, all these x's we want to enter, and all those y's. So we'll have a race. We'll see who does not beat me. You should all beat me. I'm using this digital one. I can't type that fast. All of them? Click, 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 click. Okay, 11, 10, 5, 3. If you don't beat me, you're not trying hard enough. 165, 265, 295, 12, 300, 263. What do you mean? Okay, guys, if you don't have a graphing calculator, you should be getting one or sharing, I guess. You have to have one for your homework, too.
You guys are going to beat me because mine messed up.
Now, if this was a diploma and exam, would I try to be racing?
Yeah.
No.
Yell across the field like, race me.
Okay, don't race each other in the diploma. And when you're done entering, what should you do? Check it. Go back up and make sure it all matches. Okay? Because it will change your regression equation if one digit is off. Even if you wrote 294 instead of 295 or typed. Okay? Now as we usually do, in your graphing calculator, if I wanted to do a regression equation, what would be my next step? Okay, we can go straight to stat again. And then what? Calc. Went over to calc. And it's this time, instead of 0, we want to do a log, a natural log regression. So it's number 9. So the difference here this time is it's number 9. Okay, now don't push enter because.
What did you do once you added this and you're done the list?
Okay, we push stat again. Go over to calc and push number 9. Okay, now we don't push enter right away because what do we always want to include at the same time? Bars, over, enter for function, enter for y1. Now can we push enter? Yes. Good, so it gives me my regression equation. Let's write this down. So the equation is going to look like this. A plus b times the natural log of x. So our a value is negative 6.65. So it become y equals negative 6.65 plus, check your sign for your b value. My b value is 108.49. If it was negative, I would write minus instead. 108.49. 49 natural log of x. So that's the equation of the log regression. Okay, now, if you want to see the graph, what do we have to push? But then the windows are going to be weird. So how do we make our windows perfect? Zoom number 9, which is zoom stacked. Now, nothing happens. Why did nothing happen for me? Some of you have worked. Okay, that's some other equations. Okay, some of you got error. I'm not going to see my graph if my plots aren't turned on. Right? Easiest way is to go back to Y1 and push enter. So my plots are on. That's why nothing came up. So now if I push zoom 9, will it change? Yes, that's what you should get. Okay, so check your Y equals whenever that happens. Oh, see at the bottom here? You have random things typed in. That happens. Okay. If you ever get an error and you're like, why is it giving me an error? Miss Johnson can't help me in the diploma. What am I doing? Sometimes down in these guys, for some reason, you'll have like something weird typed in. And then when you go to graph, it's giving you this syntax. Okay. So when that happens, always go to. If you're in the middle of a test and there's an option, it says quit or go to. Go to, and it'll bring you to where that issue is. Okay. All right. So there's our graph. And it has for, now, it's asked for the x-intercept. In order to do that, we need to see it. Okay. So we have to change our windows a little bit. So for x, you need to go into a little bit of the negative, and the y, we have to go a little bit into the negative. So we're going to change this to be, instead of 0.8, we're going to start at, you could zoom out. Okay, zoom out would work too. I'm going to push this as -2, and then I'll make this -10. Or you can zoom out. Okay, and then push graph. So we just make it a negative number in x and y min. And so now I can actually see a little bit of my 0. If you zoom out more, you can see it better. Because what function this time do we have to use for our x-intercept? So x-intercept, how are we going to find that? Using our graph. What function? Second trace 2 for 0. Second trace 2 for 0. Okay. So push number 2. Now it says left bound, right bound. So you have to go left to the 0, right of the 0. So basically when it says left bound, you need a negative y value. So we're going to go to the left until I see a negative y value. Your graph, you can just hold down this left arrow. I have to keep pushing it. It's a digital version. It's down that way. So do I have a negative y value yet? No. Now I do, so I can push enter. Okay, now I want right bound. So now I need a positive y value. Got one. Push enter. And then it says make a guess. So just go down, make a guess. Okay, and this is almost 0. What do you have there for your x value? Oh, 1.06. My little cursor's in the way. Uh-oh, I lost it now. 1.106, right? It was? Okay, try it again. Second trace. Now, if you zoomed out 3, like Andrew said, it's kind of ugly looking, but you could do that. Second trace 2. So yeah, oh, okay, see, you have to be careful because you need a negative y value. Oh, I'm gonna go back to my windows. Yeah. What was what did it go to in your windows? The y value. What was the last one? 300 and some? Okay, 400. Okay, so if you make your y value just go a little bit lower on the negative, it might look a little nicer. You might get a better view, but when we do 0, second trace 2, you have to go left bound of the 0. Oh, put me way back up there. So you have to look for the negative y value. and then push enter. Sorry. There you go, negative. You can't do trace value for an x-intercept. Only, you could go y2 equals 0 and find the intersection point. Right, we've done that before. And then enter. So 1.06, like you said. So 1.06. So x-intercept is 1.06 and 0. Is there going to be a y-intercept? No. Y-intercept is none. Okay. Sorry, we need to add more to this. It also asks for, where did it go? I lost my page. There it is. Okay, it also asks for M behavior. What quadrants are we moving from? Quadrant 4, 2, 1. It also asks for domain and range. And sometimes you have to check for these because the domains might be a little bit to the right. Not just greater than 0, might be greater than a different number. Okay? So in this one, it was greater than 0 and YER. Okay, so let's try one more. Can you find the regression equation for this guy? Okay, so look at this, guys, here. Look at this. Time as a function of population. Who comes first in the description? Time. And we always say who's a function of who. Which variable is a function of which variable? Y is always a function of X. Always. So time is Y is a function of population X.
Why would they confuse us with that? Like, you're just in the unit the other way.
You need to understand that always Y is a function of X. So if they word it that way, then you have to figure out, okay, this is our Y, this is an X. And logarithmic functions, because they're inverse, that's why time is from used to be X is now Y. Because an inverse function, X and Y basically switch. Okay, so now that you know that, time is your Y, and this is your X. So that means who's going to be L1? Population, this is going to be L1 here. And L2 for Y. So you should beat me. Let's enter this in. Oh, yeah, they really are massive numbers. So it's going to be fun. 2974. Now, when you type this in, that number, 25 cents, will be stored. Okay, it might look different, but if you go back up, it actually is the proper number. Just because it's trying to... You deleted them?
Yes.
Easiest way is just reset your calculator. If I'm not around to help you. You could also use the insert. 2545553 2237724. This is it's very easy to type something wrong. 1331944. I don't hear as much clicking this time. Are you guys already done? This is where your texting skills really help you out. Get the thumb. Double thumb it. Oh. Okay, and then we start at 101, 91, 81, 71, 61, 51. Yeah, okay. So, did you already do your regression equation? No? Okay, let's do it together then. Everyone have that in? You didn't beat me? You're right, it's not a race. Okay, so stat. Okay, then what? Calc, what number are we going to do for 9 for a natural log? Oops, don't make sure you don't have that 2 in front. And then vars, y vars, enter, enter. So we always do that right off the bat. It's going to put us in Y1, and we're ready if there's any other questions that will follow. We're ready. Okay, is this what you got? Yay. Okay, so it says write the equation. Now, if the equation is y equals a plus b natural log of x. Oops, not ln. And this is what you're looking at right here. Let's take a picture of this. There you go. Right here, this is what you're looking at. I love that thing. Oh, and I love the sound. Okay, so this is what you're looking at. Now, in this question, who was y and who was x? Who was y first? Y, was it time or population? Y was time, time. So we're going to replace this with t equals. All right, what's the a value? Negative 346.09 plus the b value, 28.96. Natural log instead of x, what variable are we going to use? Guys, okay, remember, time was a function of population times your y, function of x. So x is the population. So x would be the p variable population, t for time. Remember, we said y is time, x is population. Okay, there's our equation. Can you figure out the rest of those? Answer, find the intercept. Where's my stuff? Okay, if you go to graph, what would you push? Zoom 9. It's right up here. Looks something like that. So seconds, calc for x-intercept number 2. Now left bound. This is where for sure you should beat me. You can just hold it down. Okay, we're looking for a negative y value. This is too far, right? Because you have to have a y value. There's a negative 1. Push enter. Right bound, need a positive y value. There we go. Push enter, and it says make a guess. You should have had that number. Did you have that? That would be 155,077-ish. Yep. Comma 0 is your x-intercept. Y-intercept. What's your y-intercept? None. M behavior, quadrant 4 to 1. Domain, x is greater than 0. Y element reals. Is it increasing or decreasing? Decreasing, it's uphill. And let's go to the last question. It says interpolate the year in which the population exceeds 200,000. That's letter D, C. So we want when we exceed, the year we exceed 2 million people. Question, is this the x value or the y value, population? X value, right? So this is great, because if it's the x value, how do we find the x value? Second trace, 1 for value, we can type in 2 million. If it gives me an error, what is wrong? You just zoom out, right? If it doesn't give it to you. If you push this and it was beyond your graph, then you would have to zoom out when you extrapolate. Okay, so time would be equal to 74, was it years? Years. Okay, so once your homework is 7.5, it's fairly short. You should get it done in class. If you finished and you haven't yet grabbed the extra reviews, then grab them and start working on them. Okay? Okay, then I have some other stuff to give you. And the answer for those are on the website.